Welcome guys, Sizosakhe Academy, and this is the Global Classroom. Guys, today we are dealing with arithmetics. Arithmetics. You can put an S or you can just say arithmetic. What is arithmetic, guys? Arithmetic is the study of operation systems, arithmetic operation systems. And what is that? That is when we are dealing with the signs plus, minus, multiplication, and division. These are the signs: plus, minus, multiplication, and division. It's the ability to use these signs to do calculations, to do mathematical calculations. Now, these calculations, these signs, arithmetic, and these operation systems, these symbols, they not only is arithmetic limited to this, it also goes to exponents, to roots, even to trigonometry, because these are the foundations of mathematics. These are the foundations of algebra. We will get to algebra in due course, but what we are going to be learning now today is the basics of algebra. That's arithmetics. Arithmetic is going to help us to give us the foundation, the background of what is maths. Where is maths taking us to? What is maths all about? On my first video, I explained about mathematics. What is mathematics? Why mathematics? And how to interact with mathematics. So please do go back to that video, first video, and watch it. And there I'm not using even the board on that one. I'm just basically explaining the concept of mathematics. So it would be of great help to you to understand why you should know maths. What is maths all about? You move away from this fear that people have with mathematics. Anyway, guys, this is where we are today. Please don't mind my board. My nephew and my niece find their way through. I'm hoping in time I'll get a better one, and I'll be using it to as we go on, we further take this course. Right, so this is what we are dealing with. This is what is mathematics. We are dealing with these signs. But before we go any further, I need to first take you to what the true basics of mathematics, which is numbers, because these, without numbers, they don't mean a thing. Numbers without these, it's just numerals, it's just numbers. But we need to make use of these together with the numerals, and then it will help take us forward. Right, guys, so this is where we will start. I will start with types of numbers. Types of numbers. Please bear with my handwriting. You'll get used to it in due course. Don't worry. That's one. Types of numbers. We've got whole numbers. Whole numbers. Secondly, we've got natural numbers. Natural numbers. Thirdly, we've got what we call integers. Right, they also have symbols. Right, and the symbols of these whole numbers, symbols are used so that instead of writing the whole word, you use a symbol to demonstrate or to talk about that whole number or that symbol. Okay, so we use this symbol for whole numbers. It is N and a little line here, and then N here, and then O. These are whole numbers. Then O, and O doesn't have to be this big, but I just want to make it clear to you. In fact, it's even closer to the n than it's more like this. It's a small one. And for natural numbers, we use the same n with a little line in it, but it doesn't have an O. It doesn't have an O. For the integers, we use a Z with a small line here and this side. Others use just one line, others use two lines. It makes not much of a difference. So these are the types of numbers. We still have other types of numbers like your prime numbers and many others, but we'll see that later. I just want us to focus on these for now. We have whole numbers, we have natural numbers, we have integers. Why I'm using this? Because these are the numbers we find in a number line. Right. Now let's talk about numbers. With numbers, we have what we call numerals. These are our numerals: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the numerals we have. These are the only numbers we have in the whole wide world. Every other number is built on these numbers. Every other number. So these are the numbers we have, except for what we call the infinity. We have the positive and the negative infinity, which means the numbers are carrying on from these way up to no end. And even on the other side, on the left, as a negative, way up to there's no end, right? But the most important ones are these: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have the tens. The tens are made of this, but in the tens we use a 1 and a 0. Those are the tens. We use 20, 30. You can see it's the use of 1 and 0, we got this, 2 and 0, we got this, 3 and 0, we got this, 4 and 0, we got etc. Right. So these are the numbers we have. This is what we called numerals. The numbers, the types of numbers I talked about, whole numbers, natural numbers, and integers, are derived from this. Right. So we move on to what is the basic fundamental of mathematics. I want to explain this, and please listen carefully, because this will take us, we'll use this all the way, we'll keep using it. Right, we've got, let me start here. We've got 0, let me start here with 0, 1, 2, 3, 4, 5, 6, 7, and carry on. Let me just, which means it carries on. That's a message there. It's a sign that these numbers are carrying on. There's an 8, 12, 38, 70. It carries on, millions and millions of numbers. Right, like we talked about the positive infinity. That's what it means. Okay, so these are the numbers. These numbers from here, let me use another pen, please. Okay, these numbers from here all the way, these are what are called whole numbers. These are whole numbers. Whole numbers, because they are whole, they are complete, they are a complete number. So they are whole numbers from 0 upwards, right? And from here all the way, these are natural numbers. Natural numbers. Right. These are natural numbers. Natural numbers, there is actually an argument between 0 being a natural number or not a natural number. Why? Because 0 also falls on the negative. It also falls on the positive. So the whole numbers are said to be from 0 upwards, but the natural numbers are said to be. But others are arguing that 0 is also a natural number because it's a positive number. It starts here and it goes there. But others say, but also a negative number. But now natural numbers are not negative numbers, right? So others have used, they use 0 as a natural number. Others say no, it's not a natural number. So whichever you choose, it's still the same, because what their argument is 3 plus 0 is equal to 3. 3 minus 0 is equal to 3. So what they are saying is 0, positive or negative, has no influence in the matter. It doesn't change the subject. It doesn't say anything about it. So 3 plus 0 is equal to 3. 3 minus 0, it's all the same. So the third ones, which I want to, let me use a red pen here. And then we have our 0 here. We have 1, we have 2, we have 3, we have 4. Right, this is what we have. And here we have negative 1, negative 2, negative 3, and a negative 4. These ones are the ones we call, from here right through, including 0, these are integers. Including 0, it's an integer. You saw with natural numbers, 0 is not included. With whole numbers, 0 is included. But the negative numbers and whole numbers are not included. In integers, in natural numbers, I mean, 0 is not included. Even the negative numbers are not included. But here, integers, it's the whole ancient ladder, whole thing, everything is included. And it is an integer, right? These are integers. Now, with that said, we've spoken about we need to look at now the placement value of numbers, how we place numbers in the number line, right? Not necessarily in the number line, but we're talking about numbers in their tens, hundreds, thousands, millions. How do we put them together? For instance, let's say we have 246. 246, 2 here is 100. It represents hundreds. 4 here, it represents tens, which means it's a 40. It represents tens. And the 6 represents units. Right. So if I have this, it represents hundreds, which means this is in hundreds, this is in 40s, it's 40, and this is a 6. So what's it? Hundreds, it represents hundreds, but it's a 2, therefore it's a 200. So we will have a 200 plus a 40 plus a 6. What does this help us with? It helps us with the ability to name numbers. For instance, 1246. So 1 represents 1,000. 2 is 200. 4 is 40s, and 6. So we can call this number and say 1,246. 46, because this is a 40, but this is a unit in the 40, so it becomes a 46. So it's 1,246. This gives us the ability. It gives us the ability to name numbers, to talk about numbers. Right, guys, we're going back to our number line now. Coming back to our number line, and this time I would like to use the integer one. So we have this one, and we have this one, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But remember, this side is negative, that side is positive. we don't usually, we put a negative, we don't usually put a positive because it is known on the right of the number line, it is positive. On the left of the number line, it is negative. Right, that is very important, guys, for us to know and to work with. Okay, let's come to this now. Now we want to use the addition and subtraction, but before we get there, I want us to know that this side, going this side of the number line, on the right of the number line, we are adding. When we are going this side of the number line, what are we doing? We are subtracting. This is what we are doing. By going that way, we are adding. By going this side, we are. So this is right side going towards the right. We are adding, going towards the left. We are subtracting. So here, if we are looking at this and we say 5, let's start with addition. We say 2 plus 4. So it would be 2 plus 2 plus a 4. Because we've used this sign, we are adding. We're starting from 2. This is where we are starting. We say 2 plus 4, which means we are adding. May I please use 3 just for sake of the numbers that are available here. So 2 plus 3, it means we are starting from here. This is our 0 point. It's a positive 2, it's here. We are adding 3 units. Because we are adding, we are going this side of our number line. So we're going 1, 2, 3. Where are we ended? At 5. This is where we are. 2 plus 3, 1 unit, 2 units, third unit. We are on 5. That is because we were adding. Now let's take the same 2 and say 2 minus the same 3. Let's see where we will end. We are here, but this time we are not going. This time we were adding, we were going this way, 3 units, 3 units. This time we are going this way, we are going 3 units. Let's start counting. This is our very starting point. It's our 0 point. So we say 1, 2, 3. So we see when we 2 minus 3, we get what? A minus 1. This is where we are. We moved from here. We said 1, 2, 3. Why? Because we were subtracting from here. When we are subtracting, we're going this side. Let me take it down. Let me take it down and say 2 minus a 3. It gave us a minus 1 because we were here at 2 and we moved these 3 units. These 3 units, 1, 2, and here we are. We get to a minus 1. So that's all it is about arithmetics with numbers. Just wanted to show you using the number line, addition and subtraction using the number line so that we get the sense, where do we get all these numbers? When people 2 plus 3 equals 5, where does that come from? It's basically from the number line. And the number line is giving us a clear direction on how to maneuver these numbers. If you had noticed, we already used the arithmetic operational systems. These are arithmetic operation systems. This is where we are. So we moved from this one to this one. Another thing I want to actually mention with you guys, I hope I'm not rubbing too early while you are still, but you can always write, you can always pause your machines, your gadgets, to go back to what we've written. I want us to deal with this now. Right. If you notice, let me put it in a cleaner, more polite way, or let me just... These signs sign is a greater than sign. This one is a less than. It's in comparison. A less than. And this one is greater or equal to. It's not greater and equal to. No, it's greater or equal to. And this one is less or equal to whatever number that we are using. Let's take an example. Let's look, before we even take an example, at the reference point of a particular number. If we are going to the right of that number, the numbers that follow that number are greater than the number we are coming from. What am I saying? If 2 is our reference point, therefore 3 is greater than 2, 4 is greater than 2, 5 is greater than 2. If you are coming on this side, 2 is greater than 1, 2 is greater than 0, 2 is greater than minus 1. Now, let us look at the minus or the less than sign, which means 3 is less than 4 because 3 is on the left of 4. 5 is on the right of 4, therefore 5 is greater than 4. 3 is on the left. Here I am. 3 is on the left of 4. Therefore, 4 is greater than 3. 5 is on the right of 4. Therefore, 5 is greater than 4. And using 2 here, so if I say 2 to 3, it means 2 is less than 3. Because 2 is on the left of 3. 3 is less than 4. Minus 2 is less than minus 1. Minus 1 is less than 0. Hope it makes sense. Now let's come to the greater one. Minus 2 is greater than minus 3. Hope we're still together, guys. Minus 2 is greater than minus 3. Minus 1 is greater, this is a greater sign, than minus 2. Why? Just remember this. Minus 2 here is on the left of minus 1. Here is minus 2. Minus 2 is on the left of minus 1. Hence, minus 2 is less than minus 1. Therefore, minus 1 is greater than minus 2. Hope I'm not confusing you guys, and I believe I'm not, because if you'd follow this number line method, using every number to the right of the number we are dealing with is greater than the number we are dealing with. And number to the left of the number we are dealing with is less than the number we are dealing with. I believe you have got me. I believe in your understanding. I really do. I know you are capable of understanding this. And it's so grateful of these equipments, this technology, because you can always rewind me a million times and you will get a point. I do believe that. So now I want us to look at the equal to, right? So when we say minus 3 is greater or equal to 0, is less or equal to 0, is less or equal to 0, which means we are dealing with 0 and minus 3. But we are including 0. So we are saying 0 is greater or equal to minus 3, which means from here 0, we include 0 to this number. It makes sense. It's easier to understand if I say x is greater or equal to 5. Let me put it this way so that it makes sense. It means the number I'm looking for should be greater or equal to 5. May I please use 1 so that it would be clear. Greater or equal to 1, which means the number, it starts from 1, including the equal part. It means 1 is included in the number we are looking for. 1 is included, plus many more numbers above 1. Because we have a 1 here, therefore 1 is included, greater or equal to. In most cases, we even put a sign. You will see when we do absolute values, we put a sign like this. If it's greater only, we don't shade this part. We leave it open like this. For instance, here on 1, we would leave, this is 1. If it's greater only, it's greater than 1, which means 1 is not included. So it's starting from 2 upwards. It is greater than 1. We don't include 1 in that one. So if we say x is greater than 1, we do not include 1. But if we say greater or equal to, we include 1. But what I wanted to show you, we will see when we're doing absolute values and graphs and all that, if it's greater and not equal to, greater, just left like this, we would put a 0, an open 0. And then we put our line, it carries on and on and on because it's greater than 1. So we are looking for a value that is greater than 1, which in other words, x is not equal to 1 or anything below 1. From 0, minus 1, minus 2, it cannot be. These numbers are not included, cannot be the solution. The solution is greater than 1, which means it starts from 2 to upwards to infinity. But if we say x is greater or equal to, it means we start from 1. From 1, 1 is included in those possibilities, and we shade that. We shade it like this to show that there is a possibility that here, but these numbers, these other numbers, but this one is also included. So in our solution, we would put this one as an included number. X would probably be equal to 1, or x equal to any other number, but it would not be less than 1 if it is greater or equal to 1. But you will see when we do absolute values, it will become clearer at that point. Right, so we've done this. Let us move on. Right. So another most important thing that we need to deal with is brackets. Brackets, my brothers and sisters. When we deal with brackets, we've got, let's say, 5 minus and minus 2. In arithmetics, it is wrong to write 2 arithmetic operational symbols that follow each other. So to separate that, we put a bracket. You should never, ever, ever, ever have 2 arithmetic symbols that follow each other. Be it positives, negative, positive, multiplication and division, addition and multiplication. They should never follow each other. They have always got to have a bracket that separates them. This bracket will separate them, and if we are subtracting a negative number, that number, it is the same as adding it to its counterpart. So if it's minus and minus here, it's the same as 5 plus 2. If it is minus and minus, it's the same as this. if it is 5 plus minus 2, when you are adding a negative number, it is the same as subtracting it from its counterpart, which is 5 minus a 2. This is what it does. So this is what the brackets help us. And so far we will do with brackets like this, and they will explain these brackets up to this point. So we must always remember, we don't, even if it was 5 divided by negative 2, we also have to put this 5 multiplied by negative 4. We also have to put a bracket. So we don't leave it hanging, but we will deal with division and multiplication when we are dealing with division and multiplication. For now, we are dealing with addition and subtraction. That is what we are dealing with right now. So 1 plus 2 is equal to 3. 1 plus minus 2, 1 plus minus 2 is equal to 1 minus 2. That's what it is. And we go back to our number line. We have 1 here is positive, and minus, we go into this unit 2 times, so it's 1, 2. Therefore, we have a minus 1. Because using our number line, it tells us if we are subtracting, we are going to the negative side, which is the left. If we are adding, we go to the positive side, which is the right. That is what we do when we are adding and subtracting our numbers. Hope, guys, you've enjoyed our first session of arithmetics. These are just the basics, guys, the basics, but they are important. They are very important, because if you battle with these things, maths will become a quandary for you, which shouldn't happen. It should not be a quandary. So hence I'm here trying to help you guys with all of this, trying to see if we can start from scratch, do the number line, do everything. Don't forget the types of numbers, whole numbers, natural numbers, integers, how to separate them, because that is important. Later, when we do absolute values, graphs and all that, we will come across something like this. Oh, pardon my handwriting. Something like this, where you will have an x, and then we have an element of something, could be an x, could be whatever, and then we have it like this. So this is a set, but we will talk about this. There's an element of real numbers where you have your r like this, an element of real numbers. We will talk about that later. And I'm confident we will be on the same page. Thank you so much for having me, guys. Remember, do not forget to subscribe, share, and remember that bell, to ring the bell for notifications. Thank you for having me. God bless you.